Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video we're going to build a simple snake game in Python, so let us get right into it. Now, before we get into the actual coding of the snake game, I want to mention that this video is sponsored by Tab9. And before you skip that part, because it's just a sponsorship, let me tell you that I would never recommend something or advertise something unless I think it's useful and interesting. So I'm going to use Tab9 in today's video because Tab9 is an auto-completion model that you can use in modern development environments like PyCharm, IntelliJ, or VS Code, for example. And what it does is it suggests you some autocompletion that goes beyond the basic autocompletion that you already have in PyCharm or VS Code, because it does not work with a static model, but it uses a GPT-2 language model. So it uses deep learning in combination with GPT-2 in order to suggest the best autocompletion possible, and it's also learning over time. So this means that when you're coding using Tab9 in the background, it not only gives you intelligent autocompletion suggestions, but it also trains itself to give better suggestions over time, which means that, for example, if a suggestion might not be perfect right now and you delete it, it will learn based on that deletion, and it will not recommend the same thing, or it's less likely to recommend a similar thing in the future, and vice versa. If you use a good autocompletion, or if you take a suggestion that it gave to you, it's going to give you more of those suggestions in the future. So what I want to tell you here is that Tab9 is completely free. If you want to use the free plan, it's forever free. You don't have to pay anything. You can just install it in your development environment. So you go to PyCharm, for example, and to settings and plugins, and you install Tab9, or you go to VS Code extensions, then Tab9, and you can use this free basic code completion model here. So you have a basic completion model and you have community support. If you want to pay for it, you get a better model, you get a cloud model, you get unlimited code completions, you get up to 5 suggestions at the same time, and just overall the auto completion experience is better. So if you want to pay for it, or if you even have a team with which you want to use Tab9, you can also pay for the team with even more support and more customized and personalized models, and with analytics and so on. So this is a very interesting product, and I'm going to use it throughout this video today, and you can take a look at it and let me know in the comment section what you think about it. If you're interested, you can just install it on your favorite development environment. All right, so let's get into the coding. The first thing that we want to do is we want to install Pygame, because Pygame is what we're going to use in order to build the snake game. And for this, we're going to import Pygame. Of course, if you don't have Pygame installed, you need to open up the CMD command line or your terminal, depending on the operating system. And we're going to say pip install and Pygame, just like that. This is a very simple install. And once you have Pygame installed, you import it, and then we also import 2 other modules, which are time and random. We're going to need time for some timing, and we're going to need random in order to spawn the food on random places or in random places. So we're going to say import time and import random, like that. Now, what we're going to do now is we're going to initialize Pygame. We're going to set some colors. We're going to set some dimensions. We're going to set up the whole display, and then we're going to start coding the game logic. So first of all, we're going to initialize Pygame, and for this, we're going to use Pygame, pygame.init. As you can see, we already have an auto completion here, pygame.init, and then we're going to define some colors. So let's just add some comments here. Define colors. Up here, we're initializing Pygame. And for the colors, we're going to say white equals, and I'm going to use 255, 255, 255 here. Then I'm going to say black equals, and the interesting thing that you can see here is when I start typing black, it already suggests that I can use 000. This is Tab9 autocompletion. Then I can say red equals, and I can use 25500 here. And then I can use orange, and orange is 2551650. So those are just the colors. White is going to be the color of the snake. Black is going to be the color of the background. Red is going to be the color of the game over message. And orange is going to be the color of the food that we're chasing as a snake, or with the snake. Then we're going to set width and height of this display. So we're going to say 600 times 400. And then we're going to set up the display by saying game display equals pygame.display.setMode, and we're going to set a tuple of width and height so that we have the dimensions here. And then we're going to set a title, so we're going to say pygame.display.setCaption, and we're going to call this, I don't know, Neural 9 Snake Game, like that. All right. So after that, we don't have too much else to set up. We need some fonts, and we need a clock, of course, because the clock is going to time the whole thing or keep the whole thing running. So we're going to say clock equals pygame time clock. As you can see, perfect auto completion here. And then we're going to set also the snake size and the snake speed. So let's say snake size is going to be 10 pixels and the snake speed is going to be 15 pixels. And then we're going to set two fonts, or actually we can use the same font, it doesn't really matter. Maybe one should be larger than the other one. So we're going to have a message font, so giving us information, like game over, for example, message font, and this is going to be pygame.font.sysfont, and it's going to be Ubuntu. In this case, you can choose whatever font you like. And I'm going to use size 18, or actually we can make this larger. Let's use, I don't know, 30. Maybe that's too large, but let's see. And then we're also going to have a font for the score, because you always want to know what your score is. If you eat one food, you have one score. Another food, piece of food, then you have two score, and so on. So you want to have that font as well. Score font is going to be Pygame font, sysfont, and also Ubuntu in this case, with the font size, I don't know, 25, for example. So this is the basic setup of our snake game. All right, so what we're going to do next is we're going to define two functions that we're then going to be calling later on in the main function, in the run game function. And those two functions are just responsible for updating or drawing the score and updating or drawing the snake, the full snake with its position. So the first function is going to be the print score function, or you could also say draw score function here. We're going to pass a score to it, and then we're going to say the text value here is going to be score font, which is the font that we use to write this message or to draw this message. In this case, the score, not the message. And then .render, so score font .render, and we're going to render the score, but we're not going to just render the numerical value, but we're going to say score colon and then the string of the score. So we're going to have one string here, and we're going to anti-alias it, and we're going to pass a color here, which is going to be orange for the score. So I didn't mention this in the beginning. I think I said the food is going to be orange, but this message, the score message, is also going to be orange. Of course, you can feel free to change that to green, for example, if you want to. And once we have that text object, we're just going to draw it onto the display. So we're going to say game display.blit text, and we're going to pass 0, 0 here as a position. So this is the first function. The second function is the draw snake function. The draw snake function is going to take the snake size and the snake pixels. So a snake consists of many pixels, especially if it eats a lot of food pieces. It's going to have a large size. And what we're going to do is we're going to have a list of all the positions of these pixels and the size of the individual pixel. So in this case, we're just going to say draw snake, and we're going to say for every pixel in snake pixels, we're going to say pygame.draw.rectangle, or just rect, and then onto the display we're going to draw in white color, and here we're going to now pass a list, which is going to be the pixel 0 and the pixel 1, which is just the position of this individual block, and we're going to pass the snake size here. So snake size and another snake size. So the basic idea is that we draw a rectangle. Let me just shrink this a little bit. We draw a rectangle, which is just a pixel itself, on the position 0, 1, or on the position of index 0. So we have this pixel, and this has the x coordinate and the y coordinate. At this position, we plot a pixel, or we draw a pixel of that size, of the snake size. So those are the two basic functions. All right, so now that we have all that, we can go ahead and start coding the run game function, which is the main function that we're going to call later on to start the game. And for this, we're going to say def run game. And here we're going to have to define a couple of things. First of all, we're going to say game over is going to be false, because that is a variable that we're going to use in a while loop later on, which says while not game over, do the same thing over and over again. And we're also going to have game close defined as false, because game close and game over are not the same thing. I can be game over, but still the game is not terminated. I can start a second round, or I can just look at the score. I can do whatever I want. Game close means that we're actually closing off the game. So those are two different variables here. Then what we're going to do is we're going to define a starting position. The starting position is going to be x at width divided by 2. And y is going to be height divided by 2. And since we only have 1 pixel, that's enough. And we can also define a default speed. And since we haven't started the game yet, since we haven't done anything yet, we're just going to keep this snake in the center of the screen without it moving anywhere unless we start pressing some keys. So we're going to say x speed is just going to be 0 and y speed is also going to be 0 here. Once we have that, we also need to define the snake as a list. Right now we only have 1 pixel, so that's not really important. I mean, we have a pixel or 1 block, you could say it's not a pixel. But we have only 1, so a list is not really necessary. But over time, the snake is going to grow in size, so we need to add some more blocks to it. And for this, we're going to say snake pixels is going to be an empty list. And the snake length is currently 1 in the beginning, since we don't have anything but this 1 pixel in the middle of the screen. Now, once we have that, we need to also spawn a random target, or the target is not random, but the position of the target is random. So we need to have some food somewhere in the map that is not out of bounds. And for this, we're going to say target x, or food x, you can call it whatever you want, is going to be around random.randrange, not randrange, but randrange. And it's going to start at 0. And it's going to go to width minus the snake size so that we have enough space to fit in the snake itself. And then we're going to divide the result by 10 as a floating point number so that we get a floating point result. And then we're going to multiply the whole thing by 10 floating point. And we're going to do the same thing for target y. And here we're going to use the height and not the width. So we're going to say height. There you go. And that is how we spawn the random targets. All right, so now we're going to start writing the game loop, the main game loop, which is going to be while not game over. So while we haven't lost yet, we're going to say for event in pygame event.get, which is a great autocompletion again. We're going to say if that event, the type of this event is pygame.quit, so if that's the event, then we're going to say game over equals true. Otherwise, if the event type is not quit, but if the event type is going to be pygame.keydown, if that is the case, and we actually want to have this, come on, like that. If the event is key down, we're going to ask for which key we actually pressed. So we're going to say if the event key, so if event key equals pygame.k, and then we want to know if it's left, for example, we're going to do different things than if we press up, down, right, and so on. So if we press left, what we want to do is we want the snake to go to the left. So we want to change the speed so that the snake goes to the left as much as it is, as much as the size it has. So we want it to move 1 block per second or per clock tick to the left. So what we're going to do is we're going to say x speed is going to be negative size. So it's going to be negative snake size. Why negative? Because if you have a Python, window, maybe it's better if I show it with a mouse because here it's inverted. The top left is 0, 0. And the more you move to the right, the more you're increasing the position. The more you move down, the more you're increasing the y position. So if you go to the left, you're actually decreasing the x coordinate or the x position. And the y speed is going to stay 0 or to become 0 because we cannot move diagonally in Snake. So we're just going to set this to 0. And we're going to repeat this process for if event key is going to be PyGameWrite. Then we're going to say x speed is going to be the snake size, so the positive snake size, and the y speed is going to be 0 again. Then if event key is pygame.k_up, then we're going to say x speed is going to be 0, y speed is going to be negative snake size, because again we're moving up, so we're decreasing the y coordinate. And then if the event.key is going to be pygame k down, then we're going to say x speed is 0 and the y speed is going to be negative, not negative, it's going to be positive snake size, because then we're moving down and increasing the y coordinate like that. Now we need to take care of the indentation here. There you go. So this is the basic thing that we're going to do. And of course, if we hit the boundaries, so if we go out of the screen, we're going to have to close the game as well. So we're going to just say after that, so after the for loop actually, so here we're going to say if x is larger or equal to the width, so if we reach the right limit, or if x is less than 0, which means we reach the left limit, or if y is larger or equal to the height, or if y is less than 0, then we're going to say game close equals true, which means that we lost, but we didn't quit, but we just lost. So we're going to move to a screen that we haven't defined yet. We're going to add it up here, but that's the basic idea here. So then what we're going to do, of course, is no matter what we did, maybe we did nothing, maybe we increased the speed, or we changed the direction, we cannot really increase the speed. But whatever happened, we need to advance. So what we need to do is we need to say the position of the head is going to be increased by the speed. So if the speed is 0, if the x speed is 0, because we're going up or down, nothing is going to change. Otherwise, it's going to change depending on the speed. And here we're going to say y plus equals y speed. So this is just the movement, and this is how we move the snake. So we wait for the events. If we quit, we quit. And if we get a key press, we're going to change the speed. And with each iteration, we're going to change the position based on the speed. So now we have all the information about this game. We know where the snake is, we know where the target is, we know what colors we want to use, we know the speed of the snake, we know what key we pressed and so on. But we haven't drawn anything onto the Pygame window yet. So this is what we need to do next. And the first thing we want to do is we want to set the background. So we're going to say GameDisplay.fill with black color. This is just the background. And onto that background, we're now going to plot the target. We're going to draw the target piece. This is just going to be a snake-sized square that is going to be the target. And for this, we're going to say Pygame.draw.rectangle onto the game display in orange color, and the position is going to be target X that we already have, target Y that we already have, and it's going to be snake size and snake size. So this is just the basic target, and what we need to do next is we need to update the snake, which means that we need to add the head of the snake, which is constantly moving, to the list of the snake pixels, while also removing the tail so that the snake moves and it's not just growing all the time. So we need to add the head, and we need to remove the last piece of the tail constantly. And of course, we don't want to remove the last piece of the tail if the snake length increased. So if we actually got a target, so because then the snake actually gets longer. And what we need to do in order to accomplish that is we need to say snake pixels dot append, and we're going to append the current position x, y to the snake pixels. And afterwards, we're going to check if the length of the snake pixels is larger than the snake length, then we're going to delete the tail. So we're going to say snake pixels 0. So the idea is that we start with an empty list which has length 0. We have the snake length of 1, which means that when we add this initial pixel, it's not going to delete anything. It's just going to move around that pixel. And if we, and it's going to it's not going to do anything, but if we have more pixels, it's going to move the head and move all the other pixels as well, and it's going to always delete the last pixel so that the snake is not growing automatically. But of course, if we then find a target, if we eat a target, we're going to increase the snake length, which is going to allow for one more block to pop out in the end. So this is the basic idea here. And then we're going to say for pixel in snake pixels up until the last block, up until the one before end, we're going to say if this pixel, so we're checking all the pixels except for the head. If this pixel, or if one of those pixels is in the same position as the current, let me just remove this, if pixel is in the current position of the head, this means that the snake ran into itself. So if you have like 5 blocks and the snake is going right, and without going up, immediately turning to the left, it's running into itself. Or if it's just going in circles and bumping into itself, this means that the snake crashed into itself, and this is also game over. So what we need to do here is we need to say game close equals true. Then, of course, we're going to plot the actual snake and the score. So we're just going to say draw snake, which is the function that we have defined above. We're going to pass the snake size, and we're going to pass the snake pixels list. And then we're also going to print the score, which is always going to be the snake length minus 1. Why is it going to be the snake length minus 1? It's going to be the snake length minus 1 because we start at a default length of 1, which means that we haven't done anything and we already have a length of 1, but we still want to have a score of 0 because we haven't done anything. And when we got to one target, when we eat one piece of food, of course, we want to have a score of 1, even though the length is 2 and so on. So this is why we have snake length minus 1 score. And then we're going to say pygame.display.update so that the changes actually happen, or all the drawing that we did actually happens on the display. And once we have that, we need to check if we are running into a target. So if the head of the snake is at a position where a piece of food is, then we're going to say, okay, we can eat that piece of food, we can respawn a new piece of food, and we can also increase the snake length by 1. So we're going to say if the current position is the same position as the target position, so if x equals target x and y equals target y, if that happens, we are in the right position, and we're going to spawn a new target, which means that we're going to just copy these 2 lines here. And there you go, come on. And after that, of course, we're going to increase the snake length by 1 because then it's not going to delete the tail immediately like that. And of course, don't forget to do a clock tick in the end because otherwise we don't have any progress. So clock tick and snake speed is going to be what we pass here. And once we're done with all that, so if we get out of the loop, we're going to just say pygame.quit and just quit in general. And we're going to run the game. So last but not least, we're going to make use of this game close variable here that we have because we haven't used it up until now. And what this is going to be used for is for a game over screen so that the game doesn't just disappear once we crash into a wall or into the boundaries or when the snake crashes into itself. We don't want the game to just end. We want to have a game over screen and maybe the option to restart the game instead of just closing it. And for this, we're going to go inside of the game loop here and we're going to say while game close, which is interesting because this serves also as an if, because if the game is closed, we're going to enter this. Otherwise, we're not going to enter it. But when we enter it, we're going to stay inside of the while loop as long until, or as long as game close is true. So we need to change it in order to get out of it. And for this, we're going to say, first of all, we're going to fill the screen again with black. We're going to say game over, and we're going to say, we're going to show the score, and then we're going to have the possibility to restart the game or to leave the game. So we're going to first say game display fill, game display.fill. We're going to fill it with black color, and then we're going to have a game over message, and the game over message is going to be message font render. There you go, perfect auto completion, game over like that. We're going to use anti-aliasing and the red color. And we're going to say game display dot blit game over message. There you go. And the game over message is going to be positioned in width divided by 2, height divided by 2. We can also do divided by 3. Shouldn't be too ugly. And then we're going to update the score again. So we're going to say print score snake length -1 and pygame.display.update so that we actually see the changes. And once we have that, we're going to wait for user input. So if the user inputs or if the user presses 1, or if the player presses 1, this is going to quit the game. If the player presses 2, it's going to restart the game. So we're going to say for event in pygame, pygame event get, auto completion again here. If the event type is going to be pygame key down, if this is the case, we're going to check which key was pressed. So if event key equals pygame.k1, then we're going to quit. And in order to quit, we need to exit this loop and we need to exit this loop. So we need to set this here to false and this here to true. So we need to say game over equals true and game close is going to be false, so that we exit all of that. And once we have that, we can also say if event key equals pygame.k2. So if this is the case, we're going to restart the game. And in order to restart the game, all we need to do is we need to just recursively call the run game function. And that's it. Now, alternatively, we can also say if event type is going to be pygame quit, then we can also just do the same thing that we did up here. And there you go. This works perfectly fine as well. So we're finally done and we can go ahead and give this game a try. We can just start it and you will see that we have a score 0. We have a white snake in the center of the screen. We have the target down here, which is very unfortunate because it's very hard to get there. I hope I won't fail. There you go. And there you go. Score is 1. And we can just go ahead and play snake for a while here. I'm not very good at that game. Come on. There you go. Score 2. Score 3. Score 4, and so on. And after a while, you can just decide to crash into the wall, for example. Then you have game over. If I now press 1, it's going to quit. If I press 2, it's going to start the game again. And I'm going to show you that I can also crash into myself. So I just have to collect a little bit of food. Like that. Come on. And one more maybe. And one more maybe. So now I should be able to, or maybe one more, come on. I should be somehow able to crash into myself. Now, the problem is right now I crashed into myself, but it was because I was going right and then I turned left without going up or down and then I crashed into myself. If you don't want this to be possible, you can just say, okay, if there is a block, if you're currently going right, you cannot just go left. If you're going up, you cannot go down. You have to go like first right and then down if you're going up, for example. But otherwise, you're just going to crash into yourself. If you're long enough, of course, you can also crash into your tail. You don't have to crash into your second block. But that's how it's going. And now we can also press 1 and the game is quit, or the game did quit. And this is how you build a simple snake game in Python. So that's it for today's video. I hope you enjoyed and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Also, don't forget to check out Tab 9, install it in Visual Studio Code or in PyCharm. It's an interesting product, it's very useful, and the auto completions are quite interesting as you saw in this video, so make sure you check it out. And other than that, thank you very much for watching. See you in the next video, and bye.